Hi again, boys and girls. It's Miss Messina from Team Cortland.
Hi, everybody. It's Mrs. Cabrera from Team Stony Brook.
Hi, everyone. It's Mrs. Viola from Team Geneseo.
Hi, everybody. Mrs. Levin from Team Purchase.
Hi, guys. Miss Hidalgo from Team Geneseo.
Hi, guys. Mrs. Schwartz from Team Cortland.
So, boys and girls, good morning, everyone. Today we're going to explore another new topic in our chemistry unit, finding volume using the water displacement method. Let's first review a few concepts from the other day. Do you remember what mass means? Well, mass is the amount of matter inside of an object. So in easier real-life terms, it is the amount of stuff that makes up an object. Think about your body. Your body is a form of matter, and everything inside of it, like your blood, your organs, your cells, etc., make up your entire body. This is what we call the mass inside your body. Mass is measured in units known as grams.
Now let's review another important term, volume. What do you think volume is? Volume is the amount of space an object actually takes up. Let's think of some easy examples that will help you understand what volume is in your everyday life. When you play the radio and you hear music, if you lower the volume, you may only hear it in a small area of the room. But if you raise the volume, the music will take up more space and spread out into other parts of the room. So volume is the amount of space an object takes up. That's a great example.
Now let's talk about density, which we'll review. What is density? Density is the measure of how compact the mass is in a given substance. Let's think of real-life examples to help you understand exactly what that means. Some examples of dense materials can be lead, iron, or even a hard rock. Some examples of less dense objects can be materials that are loosely packed together, like a liquid, or even better, a gas. Density is important because it can determine if an object will sink or if an object will float. Less dense materials tend to rise above more dense materials.
So now that we've reviewed these three important terms, mass, volume, and density, we can move ahead into finding volume by using the water displacement method. Let's think, what does water displacement mean? Well, exactly what it sounds like. Water gets displaced to an area where from where it was originally placed. Let me give you a real-life example. Have you ever filled up your cup with water and then added ice cubes? What happens to the water in the glass besides getting cold after you add the ice to the glass? Doesn't the water level change? Is it the same, or did the water level rise?
Let's talk about this. Can we use water displacement method to tell the volume of the ice cube, meaning how much space the ice cube actually takes up in the glass? Can we use the original or initial level of water in the glass before we added the ice cube, and also the higher level of water in the glass after we added the ice cube to the glass to figure this out? Is there some mathematical equation we can use with these two measurements? In this lab activity today, we will have the opportunity to find the volume of different items that are irregularly shaped. In this case, we will use 5 rods made of different substances, a graduated cylinder, and water. You may use your calculator, also found on your iPad, if necessary.
Let's take a look at my equipment I have here. You can do this at home if you want. You won't have the same things that I have, but you'll be able to figure it out. So the first thing is I have a graduated cylinder. I'm sure you don't have a graduated cylinder at home, but maybe you have a cup measure that has markings on it. So this one has markings on it in milliliters inside, so you can see how many milliliters it is. So if you have something like that, you can use that. Yesterday we learned how to measure the volume in a cube, and with the cube we just knew that it was length times width times height. But what happens if you have something that's not a cube? Okay, what if you have something that's like a cylinder, or what if you have something like a toy dinosaur or a necklace or something? That's pretty hard to calculate the volume. But today we're going to learn how to measure the volume. So the first thing we're going to do is I'm going to put 50 milliliters of water inside my graduated cylinder. I'm going to fill up exactly 50 centimeters. Can you see that's exactly, and you can tell it's milliliters because if you look at the top of the graduated cylinder, it shows you that it's milliliters. So we have exactly 50 milliliters. I want you to watch carefully. I have a whole bunch of cylinders that I'm going to put in, and you can put anything you want in as long as it fits. I want you to notice that when you're looking at the graduated cylinder, it doesn't show that much in the plastic, but you'll notice that the water level kind of dips down. I have a glass here to show you even better. Notice how the surface of the water looks like it dips down a little bit. That's called the meniscus, and you always read the bottom of the dip. So you have to get your eyeball right at eye level, and then you have to read the bottom of the dip. So coming back to the graduated cylinder, how much did we put in there again? 50 milliliters. So we put in 50 milliliters. And now I'm going to add cylinder A, shiny gray cylinder. If I add cylinder A, what I want to do is I want to tilt it sideways so it doesn't splash, because if the water splashes out, then what are we really measuring? Nothing. So I'm going to slide it in nicely. What did you notice happened to our water level? Did you notice that the water level went from the 50 milliliters? Now it is at, it would be 72 milliliters. So what happened? Is that cylinder now 72 milliliters? No, that's the water level, is 72 milliliters. What did we start out with though? How much water is actually in here? Do you remember we measured 50 milliliters in there? So it was 50 milliliters. How much is that cylinder? Well, the cylinder took up enough space so that the water level went up to 72. So then if you do 72 milliliters, which is what we have now, minus the 50 milliliters that we had originally, how much is in there? 72 minus 50 is 22 milliliters.
Wow, that makes sense, Miss Levin. If I subtract the starting water level from the final water level, I will get the volume of that solid rod. Can you do some more practice for us?
Sure.
I have a question though. What would be the best unit to write after my measurement since the rod is solid and not a liquid like water?
Great question, Ms. Cabrera. We would use the units ml after the two water level measurements because we are measuring liquid levels. But when we write a unit for volume of an irregular shaped solid, meaning the rod, we use the units centimeters cubed instead of milliliters.
Let's continue watching Mrs. Levin find the volume of all the other rods made of different materials.
Right now, we're going to fill up our graduated cylinder to the same 50 milliliters. Again, we're going to tilt the rod gently, or we're going to tilt the graduated cylinder gently, and we're going to put in rod B. And we went up to 66. Is the volume of the rod by itself 66 milliliters? Do you want to try another one? Again, we're going to fill up the graduated cylinder to exactly 50. We're going to put in C. So that is 59. Let's do D. Definitely 63. We're going to put in E, slide it down. 66. To find the density, you take the mass that's given to you in your chart and divide it by the volume, and that will be your density. And then you can match it up using the chart down below and see what our materials are.
Now, boys and girls, let's make sure to definitely complete that chart on the PDF together. And later we'll be able to calculate the density using the given mass and the volume you have just figured out.
Finding the density is easy after you know the mass and the volume. Do you remember the formula that we used?
Yes, density equals mass divided by volume.
Yes, it's just a simple division process. You can use calculators to help you with the math. Remember, you have a calculator on your iPad.
Easy way to remember mass is divided by volume is to draw a heart. Notice how it looks like an M divided by volume. So when you use the calculator to figure out density, make sure you put the mass in the calculator first, then press the division symbol, then write in the volume, and that will give you your density.
One thing that is really interesting is if you do this, if you want to see if your gold necklace is real gold or your silver necklace is real silver, you can do the same thing by measuring the mass and the volume.